The title of this tutorial is Multisim Sources. We will look at a few of the many sources available with Multisim, both voltage and current sources. The one on the screen at the moment is one that has been used in several tutorials thus far, namely the sinusoidal function. Now, let's look at the various parameters involved in the sine function. We double click on it. We have the peak value is 10 volts. There is no offset. This would provide a DC level that could be added to it, and the frequency is sitting at 1000 hertz. You can add a time delay, a damping factor, and a phase angle. I will look at the phase angle in just a few minutes, but first let's look at what is appearing down here. All of the data from the middle down is applicable to frequency response type analysis, so it's not really used in transient analysis. So we're going to click OK on this and take a look at the response, which we have seen in other tutorials as well. But nevertheless, if we go to transient analysis, and it's been set here from 0 to 2 milliseconds with a time step of 10 microseconds, and we click on simulate, and I'll enlarge this, and you see that we have the sine function that starts at 0 at t equals 0, and it's going through 2 cycles. Okay, let's illustrate how we can change the phase angle. Suppose I want a cosine function, for example. The cosine function is 90 degrees ahead of the sine function, so I enter plus 90 and click OK. And once again, I will click on transient and run it through the same time frame. And we have the function starting at 10 volts at a maximum, which is the cosine function. The next source that I will demonstrate is that of the bipolar voltage. This is one of several signals that can be used to generate square waves. So I have the bipolar voltage here, and you'll notice that it's set at 10 and minus 10 at 1000 hertz. Let's see how that is done. Okay, the positive pulse voltage is set at 10. Now this can be a little confusing because it says the negative pulse voltage, and I think the first time I did this I put minus 10 in here, and that doesn't work. That flips it back around again. In other words, a negative pulse really implies that it's negative, so you enter it as plus 10. There's no offset. Now it's sitting at 50% duty cycle, and let me illustrate what that means. Okay, we'll go to transient analysis again, and I'm going to go from 0 to 2 milliseconds with a time step of 10 microseconds, and I hit simulate. Well, notice what's happening here. The 50% means it's 50% of a half cycle rather than 50% of a full cycle. So I want to get out of there and go back. And this time I'm going to set that to 100. So remember that number, the duty cycle over the pulse duration, is really based on a half cycle. And a couple of parameters down here that you really don't need to do anything with those as long as you're working at relatively low frequencies. Now, if you were getting up in the microwave region, you might have to go in and modify the numbers here, but the rise and fall time are down in the picosecond area. So let's click OK again and go up to transient and simulate, and we have a square wave that is oscillating between plus 10 for a half cycle and minus 10 for the other half cycle, and the period is 1 millisecond, meaning we have a 1 kilohertz. Now suppose I just want a unipolar square wave. Let's go back and illustrate how we would accomplish that task. I open this up again, And this time, instead of 10 for the negative pulse voltage, I'll put 0 in, but I'll leave this at 100% and click OK. And again, transient, simulate. And now I have a square wave that's oscillating between 0 on one half cycle and 10 on the other half cycle. The next waveform that I will consider is that of the triangular voltage. Now its default value comes out as 5 volts with a period of 1 millisecond. Let's take a look at that and see what we have. Well, here's the 5 and the 1 millisecond, but we can also put an offset in here in order to get a symmetrical voltage with a 0 DC level. You have to put in an offset. Let's take a look first, though, at the signal as it comes out in its default form. Okay, I'll go to transient. Oop, I need to get rid of that one. Okay, go back to transient. And again, I'm set at 2 milliseconds, which would be 2 cycles. With a time step of 10 microseconds. I hit simulate, and you see we have a triangular voltage whose period is 1 millisecond, meaning a kilohertz. However, it starts at 0 and goes up to 5. Now suppose I would like to have a 20 volt peak to peak centered at 0. Well, to accomplish that, I have to put 20 in here and then a offset of -10. So I click OK, and I go back to transient analysis and hit simulate again, and I have the triangular waveform. It is now oscillating from -10 to +10, meaning it has a DC component of 0. So that is the triangular voltage. You can also convert it into a sawtooth voltage by adjusting the parameters. A convenient voltage for digital work is that of the clock voltage. Now the clock voltage, the default value is 5 volts and 0. And you see here a frequency of 1 kilohertz. Duty cycle of 50%. You can change the duty cycle on it. The voltage is 5. There is no offset directly with this particular voltage, so it's primarily used when you only have one polarity. If we click OK on it and do a transit analysis over the same time interval that we have performed for the other waveforms, we get a voltage that oscillates between 0 and 5 volts. Just to show something drastically different from all the other waveforms, we have thermal noise, that particular source on the screen. I'm just going to run through a short demonstration of that source. If we go to transit analysis and just leaving the parameters in that have been used on the other waveforms and hit simulate, you can see random noise. This type of waveform is useful when you're dealing with communication systems and testing the process of looking at the response due to random noise. Anyway, this concludes some of the demonstrations for a few representative sources, but there are really numerous types of sources available in Multisim, and the best way to deal with that is just take the sources, look at them, look at the parameters, and run some tests on the screen.